The last topic we're going to look at in this unit is systems of linear inequalities. So instead of just looking at solving equations or systems of equations, we're going to look at inequalities, and the way that we're going to do these is by graphing. So the first one I want to look at, it isn't a system of inequalities, it's just a simple inequality. And I just want to help you get the idea of what we're going to be doing with these. So the first thing you want to remember is that whenever you're thinking about a line, let me just put a note up here. The equation of a line, remember, is in slope-intercept form, y equals mx plus b, right, where m is the slope, or our rise over run, and b is our y-intercept. So whenever you're trying to graph one of these systems, you want to start by solving for y and putting it in that slope-intercept form. All right, so if we look at this equation in example 1, 3x plus 2y is less than or equal to 6. Let's go ahead and rearrange this and put it in slope-intercept form. So I'm going to subtract 3x from both sides, which would give me 2y is less than or equal to negative 3x plus 6, and then divide by 2 on both sides. So y is less than or equal to negative 3 over 2x plus, and then my 6 over 2 would be a 3. Okay, so that means that our slope is negative 3 over 2, and our y-intercept is the point 0, 3. Okay, so we will deal with this inequality in a second, but for now, just graph it like you would a typical line. Don't worry about the inequality just yet. Just worry about graphing the equation y equals negative 3 halves x plus 3. Then we'll worry about the inequality. Okay, so we have our y-intercept at the point 0, 3. And then our slope is negative 3 over 2. So from our y-intercept, I'm going to go down 3 over 2. And that would give us a second point here at 2, 0. Okay, and then just remember to graph a line, you just need to connect your points. That's not very good. Let's try that again. It's a little better. Okay, so we have our line here then. All right, so now after we have our line graphed, then we worry about the inequality. So in this case, we're looking for where this function is less than or equal to 6, okay? So let me actually look at this one. So when we have that less than or equal to, remember less than graphically means below. So in this case, we're looking for everything that is below or on our line negative 3 halves x plus 3. Well, if we're thinking about everything that falls below that line, it would be everything over here on this side of our line. So what we're going to do is we're just going to shade this entire region over here. So when you're solving these linear inequalities, it's different than when you're solving a system because you don't have a point as your answer, but instead we're going to get this region of a graph that we had shaded in representing the different possible solutions to this system. Now what this is basically saying then is that any point that you could find within this shaded region would be a solution to this inequality. So for example, I could just pick an arbitrary point over here, so say negative 6, 2, if we plugged it into our inequality, it would be true. It would be a solution. And anything that's outside of that shaded region is not a solution. Okay, so when we're talking about systems of linear inequalities, we're going to have two or more equations that we're graphing. We're going to shade the regions corresponding to each of the inequalities, and then the solution will be the region that is is shaded by both, so the overlapping region essentially of our two inequalities. So let's go ahead and take a look at this second example. Okay, so since there's two, I'm going to go ahead and label them again like I've done in the past. And let's go ahead and just start with the first one. So just like before, I want to isolate my y, put it in that slope-intercept form. So I'm going to subtract my 3x over. And then divide by -1. So I get y. Now here, remember, whenever you divide by a negative number, you have to flip the direction of your inequality. So this would become y is less than or equal to 3x minus 6. All right, so if we go ahead and graph this one, our y-intercept is 0, -6. Our slope is 3, or 3 over 1. So I'm going to go up 3 over 1, which would put me right here at 1, -3 for my second point. All right, again, sketch in our line. Okay, and I always like to label them just so that I can keep track. All right, now this one, if you want to go ahead and do your inequality now, you definitely can. So we're thinking about where this is less than or equal to, right? So we would again be shading everything that falls below that line. So everything that falls below that line would be everything over here. I know this isn't our answer yet. This is just for the first inequality. All right, so now we've got to go and tackle the second one. Okay, so we're going to do the same thing with this guy. We want to solve for y. So I'm going to start by subtracting the x over. So I'm looking at the second equation now. So I'm going to subtract my x over to give me 2y is less than or equal to -x plus 2. And then divide by 2 on both sides. So we get a -1/2 x plus 1. All right, so our y-intercept on this one is a +1. And our slope is -1/2, so down 1 over 2. And again, just connect your points with a straight line. Okay. All right, now this time, if we again look at our inequality, we want to know where this is, y is less than or equal to -1/2 x plus 1. So less than or equal to, again, means below. So everywhere that falls below this line. So that would be all of this. That's below that line. Okay. All right. Now, of course, now that we look at this, we can see if we're trying to solve the whole system, right, we're looking for where these two shaded regions overlap. So with our first equation, we had all of this shaded in here. With our second one, we had all of this shaded in here. But now the overlapping region is just this little piece that falls right in there. So if you want to on your paper, go through and do all of this shading, you definitely can. And then you can just maybe like take a darker color or something like that and just shade that a little bit more obviously so you know which region you're looking at as your final answer. You could also do sort of the yellow and the blue shading in your head and then just shade the final region for your final answer. So that's kind of up to you whether you like to see it all on paper or you want to just sort of keep track of it in your head. So let's go ahead and look at another example and sort of see how this works again. Okay. All right, so let me change this one because I want to show you guys something. Let's say these are just less than and greater than, not equal to. I want to show you how that compares on these graphs. So let's again call this equation 1 and 2. And we're going to do the same as before. We're going to put them in slope-intercept form, graph them, and shade the correct region. All right, so with our first equation, I'm going to go ahead and subtract that 4x over. So I get negative 5y is less than negative 4x. And then divide by negative 5 on both sides. And remember to flip your inequality because you're dividing by a negative. So y would be greater than 4 over 5x. Okay. All right, now it's not written here, but there is, of course, that understood plus 0 as our y-intercept. So our y-intercept is just at the origin. And our slope is 4 over 5. So up 4 over 5 and plot your second point. Okay, and then just connect those points with a straight line. And we have our first graph. Okay, now remember a second ago I changed this so that our inequality, I lost the equal to part of it. So we're looking for where y is strictly greater than this line 4/5 x. So the only difference that this is going to make, if you have a greater than or a less than without the equal to, instead of graphing a solid line, you're going to graph it as a dotted line. So if your inequality does not have the equal to part of it, graph your line as a dotted line instead of a solid line. That's the only difference that it makes when you're doing these problems. Okay, so now greater than means above. So we're going to be shading everything that falls above this line. Okay, so that would be everything up here. Okay, now let's tackle our second equation. So looking at the 2x minus y is greater than 2. Again, putting it in slope-intercept form. So subtract the 2x over. We get a negative y is greater than negative 2x plus 2. And then divide by negative 1. And remember to flip your inequality again because we're dividing by a negative. So y is less than 2x minus 2. All right, so this time we have our y-intercept of negative 2. We have our slope of 2, or 2 over 1. I'm going to go up 2 over 1. And plot my point. Okay, so connect your points with a straight line. And we have our second equation. Okay, and this time we are looking for where y is less than 2x minus 2. So we want everything that falls below that line. So everything below that line. Oh, and again, actually, let me real quick here remind you that since this is strictly less than and not less than or equal to, again, we want to make sure that this is a dotted line. Okay, so if it's not equal to, it's a dotted line. Okay, now let's go ahead and shade below that line. Everything below. Okay, all right, and then in the end, we're just looking for the region where these two shaded areas overlap, which would just be this little triangular region up here at the top right. Now again, if you want just to sort of pick a darker color and shade that in so it's a little bit more obvious, you can. I'm just going to shade that a little bit darker than the rest just so that it's obvious which region we're looking at. All right, let's go ahead and look at one more example. I'm going to jump down here to part D. All right, now this one's a little bit different because we have 4 equations. So we're going to handle it the same way as before. It's just that we have more equations to work with. All right, so equation number 1. Okay, ignore the inequality for a second. Think of it just as if it were an equal sign. X equals 0. Well, you guys hopefully remember that the equation x equals 0 is just a vertical line at the y-axis. So this first graph would just be that vertical line on the x-axis at x equals 0. Okay. All right, and it's a greater than or equal to, so we're leaving it as a solid line. And greater than in terms of x's would mean everything that falls to the right of that line. Okay, since x is our horizontal variable, you're thinking left or right. Less than would be to the left, greater than is to the right. So I'm going to shade everything that falls to the right of that line. Okay, so that's my first region. All right, next we have y is greater than or equal to 0. So again, just think about the equation y equals 0. And again, hopefully you remember that that is the horizontal line on the x-axis. So let me get a different color. So y equals 0 is the horizontal line that's right at the x-axis. And we are looking for where this is greater than or equal to 0. Since it has the equal to, we leave it as a solid line. And greater than for y's means you're looking at everything that falls above that line. Okay, so everything that falls above that horizontal line. Okay, so already with just these first 2 equations, we've limited ourselves just to working with quadrant 1 over here. Okay, so we know that we're going to be in quadrant 1. So now let's deal with our equations 3 and 4. So let's add 3 into the mix. So again, put it in slope-intercept form. So subtract the x over, and we'll get y is greater than or equal to negative x plus 4. All right, so y is greater than or equal to negative x plus 4. Y-intercept of 4. And then our slope is negative 1 over 1. So down 1 over 1. And just connect our points with a straight line. And that's our graph. Okay, and we want where this is greater than or equal to. So we're looking for everything that is above that line. Okay, So now what we essentially have is this region in quadrant 1 that falls above that new line that we just added in. Okay. All right, and then lastly, if we add in our equation 4, again, solve for y, so subtract the 2x over, divide by 3, then we get a negative 2/3 x plus 2. So our y-intercept is at 2. Our slope is negative 2/3, so down to over 3. Plot our point. And again, just connect your points with a straight line. There we go. Okay, and we want, again, where this is greater than or equal to, so once again, everything that is above that line. Everything that's above our line. All right, so this has gotten a little bit messy here because there's a lot going on this one. Okay, so I don't necessarily recommend that you actually get out your highlighters or your colored pens and shade all of these different regions. It's often easier just to kind of do some of this work in your head a little bit and just shade the final region. But what we essentially have, we said we wanted x is greater than 0, so that put us to the right of the y-axis. We said y is greater than 0, so that put us above the x-axis. So already we were limited to quadrant 1. Then we said we wanted above this y equals negative x plus 4 line and above the y equals negative 2/3 x plus 2 line. So if we go above both of those lines, all we're left with is this region over here in quadrant 1 above that blue line. So in this case, the red line really didn't affect anything because it didn't give us any restrictions that the blue line hadn't already. So if I just get out a different color and shade this in, we're essentially going to have this region right in here. All right, guys, so I'll post the solutions to the other problems up on Blackboard. So if you want to go through a couple more examples, you can. And there is a homework assignment for this section as well. It's not bookwork, but it's a handout that's posted in the graded assignments folder. So make sure you do that as well.